Alrighty, this time around we are going to be in activity 3 of exercise 45. We are talking about sex-linked inheritance, and what happens for humans for sex-linked inheritance is that we are looking at a gene that is carried on the X chromosome. While there are some genes that are carried on the Y chromosome, the Y chromosome is so much smaller than the X chromosome that it is very rare to have additional genes carried on that chromosome. So almost always when we're talking about relevant genes that are sex linked, they're on the X chromosome. So sex linked are often called X linked just because that's the way it normally is. The X chromosome is just much bigger than the Y chromosome. The trait that they have us looking for at first is about red-green color blindness, and they have us using C's. And as per usual, I hate using C's because it is hard to tell uppercase from lowercase c's. So the way that I do it is instead of doing uppercase and lowercase, I do my normal vision up at the top of the X, and I do my colorblind at the bottom of the X. The reason that I do that is just so that I can tell the difference because uppercase and lowercase c look exactly the same for me. We do have to consider the Y chromosome, but the Y chromosome does not have a C because the gene is not on the Y chromosome. It is only on the X chromosome. So, it's a long problem here. The mother's genotype is X with a big C, X with a little c. So mom is X with an up C, X with a down C using my code. Dad is X with a little c, Y. Do a Punnett square. Alrighty, let's do the Punnett square. This time, just because I wrote mom first, we're going to put mom on top. Bring her X's down. And then we're going to put dad on the side. Okay, and then according to the laws of probability, what percentage of all of their children will be red-green colorblind? Okay, this daughter has a good copy of the gene, so she can make normal cones, she can see color, so she does not have it. She is colorblind. He has a good copy, so he can see color. He is colorblind. So basically they end up with 50% normal vision. And then, oops, I read that on the Y line, but 50% colorblind. Okay, what is the percentage of red-green colorblind individuals by sex? For the males, it's still 50-50 because here's our two males. These are the females. Females are XX, males are XY. And so he's normal, he's colorblind, so 50% normal, male, to 50% colorblind, male. And then same for the females up here at the top. Normal because she has a good copy, colorblind because she does not have a good copy. So it's still 50% normal, female, to 50% colorblind, female. Now, I do want to point out, she is a carrier for colorblindness, but she can see color, so you would have no outward way of knowing that she is colorblind. What percentage of all the children will be carriers? They said all the children. She's colorblind, he's colorblind, he's completely normal. She's the only one that is a carrier for the colorblind allele, so it is 25% carriers. And then what is the sex of the carrier? In terms of sex-linked conditions, only the females can be carriers because men only get one chance to have a good copy of that allele. They can't carry the bad allele. They would display the bad allele. So females is the answer to the very last question there. Okay, for number 2, they switch us over to hemophilia. They have us using big H's and little h's. You can differentiate those relatively easy. I still stick with my ups and downs just because I got used to using ups and downs. You can write your code like the book does, and that's perfectly fine. This is where I always tend to stress how you write your code is a shortcut to help you solve the problem. yes, there are standards that get used whenever we publish papers and we write about it in textbooks, but you can write your code however it helps you to solve the problem, as long as you tell me what your code is so that I know how you tried to solve the problem. We're all good, essentially. That said, you do need to stick with the same letters. You can't do like hemophilia H, normal N, because different letters means different genes. And so we do have to stick with those same letters. Okay, so big H, normal, you can clot your blood. Little h, hemophilia. You get one good H, I'll write that down, then you can clot, you are normal. If you get only little h's, you have hemophilia, you cannot clot your blood, stub your toe wrong, and you could bleed to death, essentially. Okay, we have a woman who is a carrier, so big H, little h, and she is going to be married. I love that they always tell us that we're getting married and we have husbands and stuff. No hookups in A&P. She is going to be marrying a normal man. What is the potential percentage and sex of their offspring who will be hemophiliacs? All right, for us to know that, we have to do our Punnett square. So, I'll put her on top again because I wrote her first. Bring her x's down. By the way, you can also write your Punnett squares bigger. I don't know why I keep making mine so small. Just to make it difficult for you guys to see what I'm writing, I guess. All right, so again, the question was, what is the potential percentage and sex of their offspring who will be hemophiliacs? So, completely normal. Carrier. So, normal, you wouldn't know that she was a carrier. Normal, hemophiliac. So, 25% overall chance, and the only way they can have a child who is a hemophiliac is if it's a male. 0% chance on the females. So the 25% is overall, and it can only be a male. If you're going by gender, it's a 50% chance of the boys. So if they have a boy, 50% chance that a boy will be a hemophiliac. If they have a female, 0% chance that the child would be a hemophiliac. What percentage can be expected to lack the allele for hemophilia? She lacks the allele, he lacks the allele, has it, is a carrier for it. So 50% lack the allele. And what is the anticipated sex and percentage of individuals who will be carriers for hemophilia? Again, only a female can be a carrier, and she's the only one there that is a carrier. So the overall percentage of individuals is 25%, and a female, because only females can be carriers. If you're going for, if they have a daughter, what's the chance she's a carrier? 50% chance that a daughter could be the carrier. And I believe that's all the questions in activity 3.